Alright, so let's flip back to yesterday. You guys crushing this. That's alright. It's morning. We're getting there. A prism is two congruent bases connected by rectangle sides. So remember, we have like a top and a bottom that match, or a front and a back that match. And then there's rectangles on the sides. So for example, this one we have is a square. If you have the purple one in front of you, the purple one is a square prism or a rectangular prism. So it has two parts, front and back, that are the same, and then all these sides are rectangles connecting them. Okay, we also have, if you have the blue one, this one's a pentagonal prism. So we have two pentagons, one on top, one on bottom, or side to side, however you look at it. And then the sides here are all rectangles. So if you look at each one individually, it'd be rectangle, rectangle, rectangle. If you have the green one, same idea. It's just a hexagon instead of a pentagon. If you have the yellow one is a cube. And remember, a cube is a special type of prism. It's where all sides are squares. Okay? So as we talk about surface area today, we're going to be talking a little bit about how these shapes are created, what makes them the way that they are. And we're going to talk about surface area. So first, let's talk about what is surface area. Let's write that definition. So surface area, we're going to be doing this for the first half of this chapter. This chapter is kind of broken up into two parts. One part is surface area for the first half, and then the second half is about volume. And then our last lesson kind of combines all of it. All right, so does anyone remember what is area? We talked about area last chapter in chapter 11. Area is like the space that something covers, the amount it covers. So when we talk about surface area of a prism, we're talking about all the areas that this covers, all the sides. So it's the sum. And remember, sum means to add. So if you need to put in that word, add between it, behind it. The sum of all the face areas, or all the surface areas, all the face areas of a solid. Okay, so we're going to be finding the surface area of each of those solids. Now there's a couple ways to do this. All right, if you take your shape that's at your desk, can you put your phone away, take your notes out? If you take your shape at your desk, one side, if you have it, some of these, they got lost because they pop out. So if you have a side that has a hole, take that off. And you can actually unfold this. Okay, so if we take out a rectangle prism, or whatever one you have, and you take it and you unfold it, it breaks it out into its different parts. So our rectangular prism here, this is called a net, and the net is how it's broken up. So each of these you can take out the inside. So here's my pentagonal prism. I can take that out and separate it out. So each one is connected. As we take a look at this for the rectangle prism, how many are the bases when I look at this prism and the net? Which one would be the bases? The long rectangles or these small ones? Yeah, the small ones. These ones are the congruent ones, the ones that match. How many bases are there? 2, one on each side. And then we have these rectangles going between. So we could find the area of these squares and then find the area of these rectangles. These rectangles all match. They're all the same amount. They match the length and their width are all the same amount in this case. So same thing here with this one. Okay, we have our bases are these pentagons, and then we have these rectangles that are connecting them that are all the same area of each one that go around the outside. So there's a couple ways to do that. We could think about it as a net, find the area of each base, and then find the area of each rectangle, and then add them all together. That's one way. The other way we can think about it is thinking about our base as one shape. So here's our base. We find the area of that. How many bases are there? 2, right? And then we can think about this rectangle, this part in the middle, as one big rectangle. Rather than thinking about it as individual rectangles, if I think about this as a long rectangle, I'd have this as my height, and my base here is the amount that actually goes around when I fold it up. It's what goes around that pentagon. So it would be the perimeter ends up being that base. Does that kind of make sense if you think about this as one long rectangle? Okay, so we'd find the area of each of these pentagons, and then the one long rectangle would be this height, and then the base ends up being the perimeter. Okay, so as we look at this, our surface area, we use capital S, capital A for surface area, is equal to, now this is kind of goofy here, it's a little bit silly, because we're going to be using B's, and before when we use B stood for base, B is still going to stand for base, but we're going to do a capital B. So 2 and then a capital B. There's not supposed to be a dot there. 2B. And this capital B stands for our area of base. Which is different than before. Before, when we saw that B, it was just a length. It was how far is the base, how long does the base go across. Okay? And then we're going to add on the area of that really long rectangle. So to find the area of that really long rectangle, we take the perimeter of the base, so capital P, times the height. And that's that really long rectangle in between. Rather than finding each of those individual small rectangles, we're going to find that long rectangle. So P stands for the perimeter of the base. Bless you. And then this H is technically the height of the solid, is one way we can think about it. But when we think height, we generally think of like standing up tall. And so what's a little goofy here is when we think about height in this shape, a lot of people writing here, sorry, that was a weird pause. So when we talk about our height of our solid, if I hold my solid sideways here, we might think that the height is like how tall it is. But if I hold my height this way, we're talking about how tall it is this way. So our height is always going to be the distance between our bases. And so that's a little bit different. Our height isn't up and down. It might be side to side. It might look like it's going front to back. Our height of our solid is the amount between the bases. And that's really important. If you're going to write down one thing today, it's this formula with each part and what the parts mean. If you're going to write down one thing today, okay, you should write this down. If you're going to write down one thing today, this is your thing. This is your formula. It's really important. It's how we're going to do all of our work today. All right, so if you think about surface area, when I look at this right here, I have a cube, not a cube, a rectangular prism. And we can kind of tell our area here. So if I look, what's the area of this bottom? How much squares does it cover? 10, right? Okay, so I could do 10, and if it's 10 on bottom, it's 10 on top. How many are on this side? It's a 5 by 3, so that would be 15 front and 15 back. And then on the other side, we have 6 and 6. So if I use my calculator here, and we find that surface area, that's one way to do it is by adding each part. So we had 12 and 12, right? And then what was this side? 15 and 15. And then the other sides, 6 and 6. And we get 66. That's one way to do it. This formula allows us to do it a little bit more simply rather than going through all that work of finding each individual part. So if I take up my base, let's say our base is this 12. Okay, actually let's do our bases, yeah. Let's do this as our base. This one would make more sense. All right, so what's the area of this base? It was 15, so I'm going to do 2 times 15 plus, now I'm going to take the perimeter. So as I count around the outside, I have 1, 2, 3, 4, 5. Over here I'd have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm going to take that perimeter 16 times our height, how long across this is, and how long across is this part. 1, 2. And we end up getting the same answer. Wasn't that cool? That was really cool. Why didn't that work? What did I screw up? Something. That's embarrassing. Okay, pretend that worked. Amazing. I don't know. It's early. All right, go ahead and glue this in. You can go glue this in on one side, left or right side. As we work today, I'm going to be using 2 colored pencils. So if you'd like to use 2 colored pencils or 2 highlighters would be a really good one, but I think I'm running low on highlighters. I'm going to use red and blue because that's what I got. So go ahead and glue this in. Alright, so go ahead and get that glued in. Alright, so get that glued in. Hey you guys, I figured it out. What was the area of this one? It's a 2 by 5. Why did I say it was 12? The area of that one's only 10. Hey look, we get the same answers. That makes me feel so much better. I was so panicked. Okay, so 62 and 62. So it's just a little bit simpler rather than finding each individual part. We can just kind of plug it in, and then we're good to go. Makes it a little bit faster. Either way, you're going to get the same answer. It's just what's faster versus what and more efficient. And sometimes a little bit more conceptually. It's really hard once we get to those hexagons and those hexagons and pentagons. It gets really hard to visualize like how many rectangles are there going around the outside. All right, so again, I'm going to use 2 colors today. I'm going to use blue and red as we go to talk about our parts here. So in this one here, we have a prism. What kind of prism is this one? Is it a rectangular, trapezoidal, pentagonal, triangular, hexagonal? Is it a cube? Triangle, good. So our base is a triangle. So I'm going to use a colored pencil here to highlight our base. And I'm going to do this one back in the back here. So I'm going to use one color for our bases today, and that's going to help us decide and kind of look and be able to depict this. Because remember, it's really hard with 3D shapes. We're trying to describe them in a 2D world. We're trying to draw them. So you have to remember that this is something that we should be able to like pick up and touch and throw at each other, but we aren't because it's drawing. Okay, so for our area of our base, we're going to start with B. We need to find three things. We need to find our B. We need to find the P, the perimeter of the base. And we need to find the height. So there's three parts to this that we need to find. And notice I skipped a part with B, a line, because we are going to need a little extra there. All right, so for area of the base, we said the base is a triangle. How do we find the area of a triangle? What is our formula? Back from chapter 11. Triangle is half base times height, yeah. So as I look at my triangle here, my formula for area is half base times height. And notice it's a little b here. That's different than this big B. Big B stands for the area. Little b stands for the side that's the base. Gets a little confusing. So we have half times what's our base and our height of our triangle here. Remember, base and height, we need to have that 90-degree angle. So where do we see that 90-degree angle? Yeah, it's kind of right here. We have that 6.3, so that would be our height. And which side does it create that 90-degree angle with? Yeah, it creates it with this one here. It's a little bit hard to see. What's this side going to be? Yeah, it's with that one that's across. So this is actually 8 here. So times 8. So half of 8 times 6.3. Okay, use your calculator. Handy dandy decimals. Half times 8. Whoops. Times 8. Oh my gosh. Times 6.3. And we get 25.2. So that's our area of the base. That's our big B. Now we need to find the perimeter of the base. So perimeter, remember, means to go on the outside. All on the outsides. So how long is this side here? 8 plus, what's this side? Yeah, that side is also 8 because it's from that one across. That's 8. We need to write that there. Remember, our front and our back bases are congruent, so they match. And then what's our bottom part of our triangle? 7. Remember, this height isn't part of the outside of the triangle, so we're doing 8 plus 8 plus 7. We get 23. So that's our perimeter. And then our last step here is to find the height. And what's a little silly is we already found the height, but that was the height of the triangle. This H is the height of the prism. So it's the space connecting the triangles. So if I look, I have kind of this triangle, I don't know, it kind of plays mind tricks on you. Sometimes to me it's like front and back, and then sometimes it's top and bottom. But we're looking at that one part that connects the triangles. So if I look at my connecting part, our height here is that 6. It's connecting it. All right, so for our formula for surface area, we're going to say surface area equals, and our formula stays the same here. It's 2 times the area of the base plus perimeter times height. And we found each of those parts, so we're just plugging them in. We have a 2 times the area of the base because how many bases do we have? 2. There's 2 triangles. So 2 times, what was the area of their base? 25.2. So again, when we talk about this capital B, we're not talking about that lowercase b anymore. This time we're talking about that whole area, 25.2, plus, now we need our perimeter, 23, and then times our height of the prism, 6. Okay, so as we put that into Desmos, we have 225.2 plus 23 times 6. Okay, in Desmos, since I have my font bigger so we can read it, it does have it all in there, but because I made my font bigger, it looks like it's cut off. And we get 188.4. Now we're talking about area, so we're still going to use the same area label. Here we have square miles, just like we did last chapter with that area. Now you might be like, why the heck are we doing this? One, Miss Morrell told you that we're doing it. But two, as we work through this, it's like if you're building something and you need to know how much space, how many boards, what's the length of the boards you need, things like that. If you're making like a dress, you need to know how much cloth you need. That would be our surface area, how much fits on the outside. All right, let's try this next one. These ones should go by a little bit faster because we're not going to explain quite as much. All right, so we need to find our capital B, our capital P, and our lowercase h. Those are 3 parts of our formula that we need to find every time for every prism. So for our base here, we need to figure out which rectangle are we going to have be our base. And with a rectangular prism, it's a little goofy because since they're all rectangles, we get to pick which rectangle we want the base, as long as we're consistent. So do we want it to be this 5 by 10 rectangle, this 5 by 8, or we could have it be this 8 by 10? Which one kind of sticks out to you as the base? The 5 by 8? Okay, so this 5 by 8, we can make that the base, that's fine. If you already did 5 by 10, because to me that's what sticks out as the base, you'll get the same answer, so just kind of keep along and see if you get the same as we do. So if you look at our bases, we have 2 of those rectangles. One kind of in front, one in back. Eyes play tricks on you, then it's top and bottom. It's a little goofy. All right, so how do I find the area of a rectangle? What is our formula? No 1/2 this time. Just base times height. And remember with our area here, it's lowercase b, standing for the base part of that. So as we take a look at that rectangle, what would be our base and our height? Based on the one that we picked, we'd have 5 and 8. 5 times 8 is 40. All right, and then we have our perimeter, and our perimeter again is of that base. So I'm adding up all the outsides of that rectangle. So if I go around, I have 5 plus 8 plus, what would this bottom part be? Another 5, good, plus 8. 5 plus 5 is 10. 8 plus 8 is 16. So 10 plus 16, 26. And then our height, this is the part that gets a little goofy, because especially since we already identified a height. This height is of the prism. So it's what's connecting our rectangle. So if I connect one point of my first rectangle to the connection of the back rectangle, what would our height be this time? 10. All right, so for our surface area, our formula is 2 times the area of our base plus our perimeter times our height. That 2 is always going to be there for prisms. Always, 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 because there's 2 bases. So if you're like, where did that 2 come from? It's part of the formula. When there's a number given to us in a formula, we always use that number. All right, so what's our area of the base? 40. Perimeter? 26, and height, 10. Throw that in our calculator. We got 2 times 40 times 26 times 10. Okay, I just put it in and we get 340. And what will our label be for this one? Yep, square kilometers or kilometers, however you say that. All right, we have one more to do. The reason why we have so many is because kind of all these area formulas are different. It's kind of a review of Chapter 11. So if you struggled in Chapter 11, you didn't do good on that test. Most people did really good on that test. You guys crushed that. But if you were somebody who you struggled with your area formulas, after this chapter, or after the first half of this chapter, you're going to be like, oh, I got it. Because we're going to do this area formula so many times. All right, so we have our big B that we need, our big P, and our little h. So we need those 3 parts always. This big B and how we find it changes based on the shape. So in our first shape, we did half base times height because it was a triangle. In the second shape, we did base times height. It was a rectangle. What's our base in this one? How many sides is our shape? 5 sides, yeah, it's a pentagon. So our sides here, this is a regular polygon. All our sides are congruent. But our base is that pentagon. If it helps you to do both and highlight both, highlight both. How do we find the area of a regular polygon? I was back in 11.4. If you look at 11.4a, we kind of had it there better. It was half. And then we did that little a. What did the little a stand for? Yeah, apothem. And then times the perimeter. Alright, so as I look at this, we have half times, what's my apothem in our pentagon? Remember, apothem connects the center to the side. So that's at 6.2, good. And then we need the perimeter, so all the way around. And this was something that I noticed some people struggled with. They wanted to just say the perimeter was 9. 9 is just one side. I need to do all the sides. So if I have 9, how many sides are 9? Yeah, 9 times 5. If you want to write that down with our perimeter down here, 9 times 5. 9 times 5 is 45. So what's kind of nice about these ones is the perimeter is the same here. When we talk about this perimeter and the perimeter before. So half times 6.2 times 45. We get 139.5. All right, because it was a regular polygon, we already had to find our perimeter to find that area. So we wrote down the perimeter. Last part is our height. So what's going to be our height of our prism this time? 6.2, 9, 139.5, 45, 12. Yeah, 12. It's what's connecting that. Good. So it should be what's already just labeled there for you. So 12. All right, last step is to plug that into our surface area formula. So surface area is 2 times our area of the base plus our perimeter times our height. That 2 is always part of our formula. So what is the area of our base? 139.5. That's the problem with doing parentheses ahead of time, is sometimes we make them too small. All right, and then our perimeter, 45, and our height, 12. Okay, so 2 times 139.5 plus 45 times 12. And we get 819. And how will we label that? Square yards. Good. Remember when we write it as yards with that squared afterwards, but we always say square yards. All right, I know notes feel long today. What's kind of goofy about this chapter is it's kind of like an every other day thing. Like one day the notes will be long, and then like tomorrow the notes are going to take us like 10 minutes. It kind of goes back and forth. So if you're feeling a little behind on homework, you can kind of anticipate if you don't finish it today, we'll have a little extra time tomorrow to finish your homework too.